teaching the concept of equilibrium of the system of coplanar forces, where that will reflect the Richard Scamm's principle of multiple embodiments. Richard Scamm's principle of multiple embodiments refers to the idea that mathematics concepts should be presented in varied forms, such as visual, symbolic, concrete representation, verbal representation. So in the video coming, you will see how these concepts or these various embodiments are exhibited in the teaching of the concept of equilibrium of a system of coplanar forces. So the next video considers the concrete embodiment. So I want two people and 3 people to volunteer and come. You stand. You stand. Good. Then you are going to all apply forces by pulling the ropes. And then we have the ring over there. Right? You are going to apply the force this way that you should apply more force. And let's see. Apply more force. Apply more force. Apply more force. What do you see the object doing? It is moving in that direction. Right? It means that the force that he is applying is more than the sum of the forces that these two people are applying. Right? Now, let's make it in such a way that they will apply the same force on the object. So relax it, then you will apply it so that the object will not be moving. So what can you say about this whole thing? That this person is applying a force, this person is applying, this person is applying, yet the object is not moving. Right? Yes. So what can you say about it? Is there any extra force that will cause the object to move in a particular direction? There is no extra force. Right? And that extra force, we normally refer to it as the what? Resultant force. So it means that as they are all applying their forces on the ring is not moving. And since it's not moving, it means that there is no resultant force. And when there is no resultant force, it means the resultant force is what? 0. Right? Good, thank you. So we saw how the concept of a system of coplanar forces in equilibrium was demonstrated through role play by the students. The next one is the pictorial presentation or visual embodiment that we are going to look at, where we will translate what we have done, what the role play that has gone on, we will translate it into a pictorial form or diagram form. So let's have a look at it. Now, what you have just seen can be translated into a diagram, a picture form, a graphical form. So if you want to translate that into a graphical form, you saw that we have a ring. So we have the ring, right? Then you saw that one rope is being pulled towards this direction. Another rope is being pulled towards this direction. Another rope is being pulled towards this direction. Right? You saw that. So the force applied by this will be called F1. the force applied by this will be called what? F2. Then we call this one F3. Realize that. Now, if we represent that, so it means that at any point in time, when you have forces acting on the body, you can always represent it in a diagram, right? Where you have the body or the particle, and then you have the forces in various directions. Are we there? Good. We realize that at this point, as you have it, we said when this force and this force and this force being applied on the body, because the body is not moving, we said that there was no extra force left to cause the body to move in a particular direction. Right? So that means that the resultant there was what? 7. Right? So if we translate this one into a triangle, where we have something like this, then we will have our force F1 here, right? Then we can have our force F2, then we have our force F3. So in translating this, we realize that the forces represent the sides of a triangle, whilst their directions are taken in order. It means that the arrows are following each other, going around the triangle. And when that happens, we say that the resultant is what? 7. Are we there? Good. Now that we have seen that, we have visually seen how the concrete presentation has been translated into a pictorial form on the board. We will now look at the symbolic or the formal or mathematical presentation of the concept of we can then say that since the body was in equilibrium, since the body or the particle is in equilibrium, then it means that the resultant force is equal to what? 0. There was no extra force. We said that. Now, we know that finding the resultant force is equal to the force F1 plus the force F2 plus the force F3. This then implies that at equilibrium, right, the vector sum F1 plus F2 plus F3 should be equal to what? 7. We are now going to look at the applied or the contextual embodiment, where the concept is seen in a real life sense. So, in real life, what's the use of these forces, equilibrium forces? Now, I want everybody to pretend and look at the fan. Look at the fan. What do you think is happening? The fan is not moving. What is it? It's an equilibrium. Why do you think it's an equilibrium? Why do you think it's not falling? It's not falling. Who are you supposed to fall? Why is it not falling? Because the handle there, I see it, is giving a force, is pulling it. A force that is equal to the weight of the fan. So far we have seen that equilibrium of the
system of forces acting on a particle can be ascertained or can be taught representing it in various forms, which included the concrete embodiment or presenting it in a concrete form, pictorial representation, symbolic representation, where we use the symbols, mathematical symbols to represent that concept, and then the application of it. So this is how the Richard Skinner's principle of multiple embodiment can be reflected in the lesson of system equilibrium of the system.